Thank you. Today I'm going to talk about building serverless Ruby bots. So basically, a year ago I was looking for an apartment to rent in the center of Zagreb. For those who don't know, Zagreb is the capital city of Croatia, which is situated in Central Europe. So basically, if you want to rent apartments in Croatia, you check out listings on an online classifieds platform that's called Njuskala. Uh, it's basically the same as Steal It that you have here or as Craigslist in the US. So I actually had a problem while trying to find an apartment. I had a hard time forcing myself to actually check the classifieds each day or maybe multiple times a day. And the problem is basically the good apartments in Zagreb go like in an hour or two. So to tackle my problem, I decided to build a small bot that would scrape that web page every 5 minutes and shoot me an email if a new apartment comes around. And this technique was actually really successful because I was always the first one to call the advertiser, and I managed to get an apartment fairly quickly. So the technical background of the bot was really simple. I only had a couple of gems. I used HTTP Party to perform GET requests to that web page. I used the Yoga gem, which is really similar to Nokogiri, for parsing HTML. Then if I found an email, I used Action Mailer to send out an email to myself. I wrapped it all up in a rake task, and I used the Whenever gem, that's like for cron jobs, to schedule that every 5 minutes. And the script actually ran on my local computer, and that was good enough for me. Basically, if I'm not on my computer, I rarely check my emails. But recently I decided to reuse the script, and I wanted it to run consistently every 5 minutes, so I had to move it from my personal computer to a server. However, I didn't fancy the idea of renting a server just to run a simple Ruby script. And I knew at that point that the ideal infrastructure for this would be a serverless one. Basically a place where I could upload my code, or just basically my function, and run it periodically without taking care of servers. And thankfully, Amazon, Microsoft, Google, and many other vendors actually provide infrastructure for this. It's usually called serverless or function as a service. And I wanted to try out the most used function as a service and the pioneer in the area, so I tried out AWS Lambda. So basically, I'm gonna go through examples with AWS Lambda, but this kind of applies to most of the vendors. So AWS Lambda lets you run your code without provisioning or managing servers. You upload your code in a zip file, set some triggers to run that code, and that's basically it. You're up and running in less than a couple of minutes. And it executes your code only when needed, it scales automatically, and you only pay for the compute time you actually consume. And Lambda's got support for multiple languages such as Python, Java, Node.js, C#, etc., but there's obviously one problem. Well, AWS Lambda, as any of the other major vendors, actually don't support Ruby. So the AWS team asked the public more than 2 years ago whether they should first support Ruby or Golang. And unfortunately for us, it was 54% for Go and 46% for Ruby. So this happened in 2015. And in January of 2018, more than 2 years later, they had a tweet that they're announcing Golang support. So it took them more than 2 years to actually add Go. And so I would guess that Ruby support isn't that close at all. So no Ruby, but I wanted to stick to Ruby and try it out on Lambda. So although there isn't any official support for Ruby, you can run programming languages like JavaScript, Python, or Java and invoke shell commands. And since you can basically invoke shell commands, there are multiple flavors of Ruby, which you can package up and run on AWS Lambda. So the three I'm going to talk about today are Traveling Ruby, mRuby, and JRuby. So let's introduce each of them. Basically, Traveling Ruby, well, if you ever wanted to distribute a CLI built in Ruby, your end users would have to install Ruby or maybe install RBN for RVM, then install Bundler, then bundle the gems or whatever, and once you would update that after like a year, they would have to go basically through the whole same process. And Traveling Ruby basically is a project that tackles the problem of distributing Ruby CLI apps. It's project by the people from Fusion that made the Fusion Passenger app server, and they supply portable Ruby binaries that can run on any Linux distro or OS 6, and with some limited support for Windows. It basically allows Ruby app developers to distribute a single package to end users without needing end users to first install Ruby or any of the gems. Uh, mRuby, on the other hand, is totally different. It's an interpreter for the Ruby programming language, and its intention is to be lightweight and easily embeddable. It's basically made for various microcontrollers and IoT devices. It's actually created by MATS, and the first letter in the name stands for either MATS or embedded or minimal. So mRuby hands out various ways to run Ruby code, and they're easily packaged into executable binaries that can be run on Linux, OS 6, or Windows, so it's technically not a problem to run it on Lambda. And JRuby, which unlike our canonical Ruby implementation that runs on an interpreter written in C, JRuby runs on the JVM, the Java Virtual Machine. So it provides a way to embed Ruby into any Java application with full two-way access between Java and Ruby code. And since AWS Lambda supports Java, there is a possibility to run JRuby on it. So I actually wanted to try out all three versions and check out how they perform. Since we have three different implementations of Ruby to run, I decided to write a really minimalistic bot where basically that only resides in one file and has like basically no dependencies, only depending on the standard library. So the first thing I had to do was shrink the code base. Previously I had dependencies such as HTTP party, Olga, and Action Mailer, and I needed to get rid of them. So the gem file looked like this, and so to get rid of HTTP party was not that much of a problem. Basically I could use the standard libraries NetHTTP. I also ditched Action Mailer in favor of NetHTTP because basically I was sending out emails with Mailgun, and Mailgun has an API, and I could ping that API with NetHTTP. I ditched Whenever and Rake because I could use the Lambda scheduler. However, I got stuck with a problem. Well, the website that I was pinging and getting my info does not have a JSON API. It basically only has HTML, so I had to have some kind of HTML parser. And while JRuby and Traveling Ruby both have Oga and Nokogiri, mRuby does not have an HTML parser. So I actually posted an issue, or more of a question, on the mRuby GitHub repository asking if there's any kind of HTML parser or any kind of recommendation. And actually Mats answered me. And he said basically that he suggested three ways. The easiest way to write regular expressions and parse HTML with that, well, I kind of didn't want to go that way because that can get clumsy if the HTML is in any kind of way complicated. The third way is to basically port a simple Ruby HTTP, simple Ruby HTML parser. Well, that's cool, but I'm not sure about you, but I don't know any kind of simple Ruby HTML parser. Basically, all of them have some C bindings and whatever and depend on external libraries, so that was not an option. And the third one was basically to write a wrapper for libxml, which is basically would be writing my Nokogiri in mRuby. And I wasn't gonna do that for such a small project. So, and all three suggestions are really legit, and I want to thank Mats for suggesting them. However, I looked at the HTML content, so I was just mentioning you. Okay. Okay, so I looked at the HTML content, and I realized that each of these listings has a time element with the date time. That's basically a timestamp when the apartment was released. And I looked at it and said, like, okay, against all of my beliefs, I'm gonna actually use regular expressions to tackle this. So I'm gonna show you the RubyBot code. It's really, really simple. So basically, you got one class that's called new apartments that gets a URL to the website, basically the URL has a lot of filter options such as, hey, I want an apartment in the center of the city. It has to be at least on the first floor. It has to have at least 40 square meters, cheaper than 400 euros, blah, blah, blah. And I inject that URL inside of it and basically perform a GET request to the website, get the response body back, scan it for those date times, and check if any of those timestamps have been issued in the last five minutes. 5 minutes because basically that's the last time that I scraped. There's basically another simple class that pings the Mailgun API. So basically, I had a search URL and a condition. If there are any new apartments with that search URL, just call the Mailgun emailer. So it's 60 lines of code, and it's pretty simple. So let's start with our first bot implementation. Implementing the bot with traveling Ruby or the packaged MRI runtimes. So first thing you have to do is download the runtimes. And you need to download the runtime binaries for each platform that you're going to use it from a list provided by Fusion off of their S3. So I basically needed to get two runtimes, one for my OS 6 machine and one Linux compatible one for Amazon Lambda. It's basically pretty simple. You just pull it down with curl on your laptop. Next up, you need to extract those zip files into their own folders. And after you delete your zip files, our boilerplate bot code looks something like this. So basically, if you expand it, it will look like this. So each of these platforms will have a bin folder inside of it and a Ruby executable inside of it. And I only drew a list of the most important dependencies. So it's basically like this. And if I copy over my bot code to a file called main.rb, the structure would look something like this. And usual Ruby execution, if you use the Ruby that's installed on your laptop, would look like this. So Ruby main.rb. However, if you wanted to invoke it with the executable you got from traveling Ruby, you would just invoke it like this: Ruby OS 6 /bin /Ruby main.rb. And that's pretty cool. Or basically, if you're running it on Lambda, you would call the Linux precompiled binary. So uploading the code to AWS Lambda. So that's actually pretty simple. There's one thing I had to do, and since Lambda unfortunately does not accept direct shell commands, I had to write a JavaScript wrapper over to execute it. And I actually didn't write this wrapper on my own. It can be found in various repositories. So basically what you do is spawn a new process executing that Ruby bot code, listen on standard output and standard error, and just on close basically get done with context. And so Lambda accepts zip files, so this means we need to zip the executable folder, the source file with the main.rb file, and the JavaScript wrapper. And that's basically it. After that, you can just go to the AWS admin panel and follow 5 easy steps to upload your bot code on AWS Lambda. So first up, you basically need to create a function. I called mine RubyBot and used Node.js runtime. Next up, you have to basically select a trigger that will invoke your function. So a lot of people use like API gateways so you can ping Lambda from the outside to trigger it, but I chose the CloudWatch schedule service. That's basically, hey, like run this bot every 5 minutes. Next up, you have to create a rule for that trigger. So that's basically where you say to it, hey, just run this every 5 minutes. Then you have to upload your functions code and eventually set some environment variables if you have any. I had like my Mailgun API key and stuff like that. And set a handler. So what's a handler? Basically, you have to tell Amazon Lambda what to invoke from your zip file. So I told him to invoke a method called handler inside of the Lambda function wrapper.js file. And that's basically it. It's 5 really easy steps, and you can harvest the benefits of your Ruby bot. And so basically, I got an email every time a new listing comes around. So there's a couple of good traveling Ruby tutorials. And provided on the GitHub repo of the project. There's like a Hello World app that's basically the same as I did. There's an app with gems. What you have to do when you install gems. There's an app with native extensions such as Nokogiri and how to handle that. There's even Windows tutorials. So you can easily find your way through it. Okay, so let's skip to implementing the bot with mruby. So there's 2 ways to build apps with mruby. You can basically download mruby source directly from GitHub, or you can use the mruby CLI, basically a platform for building native command line applications. I chose to build it directly from source just to not have any kind of abstractions over what I was doing. So basically what you first need to do is clone that mruby repo down, and you're gonna get a lot of files, but the most interesting ones are the bin folder, the build config file, and mini rake file. I'm gonna show you what each of those does. So bin folder at this moment is empty, and if you run mini rake, your bin folder is gonna get an mruby and an mirb file. What basically that means, mruby is like an executable binary with the mruby runtime for your computer, so basically for OS 6 in my case, and mirb is basically mruby's IRB. And then if I write a hello world file and basically output it from there, calling bin/mruby hello world rb will actually print out hello world. So that's really pretty simple. You can get up and running in a couple of minutes. And so next up, what I did was copy my main RB file into it and tried to run it. So I got undefined method require, and that was kind of weird. Well, remember in the intro how I said that mruby is actually really lightweight? Well, it really is. Since it's meant for embedded systems, it doesn't come with everything included. So you need to add gems for stuff that you would usually get in the standard library from Ruby. And mruby basically doesn't use Ruby gems. It's got its own set of gems called mirb gems, with a package manager actually holding the same name. And just as mruby doesn't have support for the require keyword or require method, it also doesn't have support for nethttp, environment variables, or even regular expressions. So I had to add all of these dependencies. And where do you add those dependencies? You actually add them to a build config rb file. And you can basically think of it as a gem file, or even better if you ever built a gem, as a gem spec. So I found each of those gems for what I needed. And now I had to recompile my runtime or my binary with mini rake. And basically, I would get all of those already included in the bin file. So I used the mruby gems. I had to rewrite some stuff because they didn't have the same interface. I had some trouble like writing my own ISO notation parser for working with time objects because mruby doesn't have that, but after like 15 or 20 minutes, I made it work on my machine, and basically calling bin/mruby main rb was pretty successful. And so there was a problem, like this worked on OS 6, and that's pretty cool, but I needed to get it running on Linux, and so that means I needed to do cross-compilation. And there is some library that kind of does that. I didn't make it work. I just like ported it to a Linux machine and recompiled it there, and that's basically it. The steps are really similar to the traveling Ruby. You basically have to upload your runtime, your source file, and your JavaScript wrapper, and that's it. The remaining instructions for the bot are the same as for the bot we built with traveling Ruby. So the last one is implementing the bot with JRuby. So basically, this is really simple. Like this took me maybe 10 minutes. it's basically like you download a JRuby complete jar file from their official downloads package. Uh, and to work with it, you just have to follow the steps that are on their wiki on the JRuby's GitHub repo. So I won't go through them. And what we want is actually to bundle our RubyBot code into that single jar file. And run it when the jar file is executed. So basically we can just rename it to, I renamed it to rubybot.jars because it would sound a little bit more specific when I upload it to AWS Lambda. And just copy over my main RB file to a jar bootstrap RB file, basically some naming convention stuff, and basically include it in the jar file. So what does this actually do? With this change, we change our main class for the jar file to point at org.jruby.jar bootstrap main and add our own jar bootstrap RB file to the root of the jar file. And this file will basically be automatically loaded and launched whenever we run that jar file. And basically all we have to do right now to run the code is this. And the only difference between taking this bot and the previous two is that you have to, on the AWS admin console, select Java 8 instead of Node.js. And that's basically it. Although there isn't any official support for Ruby, we managed to run 3 different implementations of Ruby on top of AWS Lambda. So let's talk about metrics and numbers. So let's compare these approaches in 3 different categories, basically code size, memory consumption, and speed. And afterwards, I'll explain to you why it matters due to Amazon Lambda's pricing. So the code size, actually, as expected, the least code size we got was with mruby, since its purpose is actually for embedded systems. However, all 3 are okay in terms of not exceeding limitations of AWS Lambda, which has, like, your function code cannot be more than 50 megabytes large. So that's pretty okay. The memory consumption, well, I actually didn't expect mruby not having a large memory. I'd expect mruby not having a large memory footprint, but it surprised me that it actually consumed more memory than traveling Ruby. But this could be also due to dependencies and stuff like that, because dependencies aren't one-on-one mapped. I'd also expect memory consumption of JRuby to be largest, but I didn't expect it to consume 150 megabytes at its peak. And kind of the problem with JRuby's memory footprint is that it goes beyond the lowest billing plan, and that's a 128 megabyte model, so you have to upgrade your plan to use JRuby. And the execution time, well, mruby is not actually, so it's meant to be lightweight, but it's not supposed to be faster than regular Ruby with MRI, and our numbers actually prove that. We had the same execution time with mruby as with traveling Ruby. So, however, JRuby is 3 times slower than the other 2, and this is actually kind of no surprise at all. So, if you run a simple print hello world RB in JRuby, it can take up to 5 seconds simply because of the long warm-up the JVM needs. So, why do these numbers actually matter? Well, it's Amazon Lambda's pricing. So, Amazon Lambda pricing's got 2 things. The first one is the number of requests you have, or basically the number of times you invoked your Lambda function. And the next one is the sum of durations of your functions that it took to execute, basically expressed in gigabyte seconds. So, the free tier has 1 million requests and 400,000 gigabyte seconds per month. With 1 million times per month, you can basically run your bot roughly every 3 seconds on a free tier. So that's pretty cool. And with the 400,000 gigabyte seconds per month, well, the metric might be confusing. It's basically your memory size multiplied by the duration in seconds your Lambda function took to execute. So basically, if you had a Lambda function that consumes 120 or less than 128 megabytes and is running for 4 seconds, you just wasted or just took 0.5 gigabyte seconds. And since traveling Ruby and mruby outperform JRuby, we're going to calculate their monthly compute time. So if we basically ran the bot every minute, that would make our bot spend less than 50,000 gigabyte seconds, and we got 400,000 of those monthly. So that's on a free tier, and like that's a really good bargain, especially if you're doing something like this. Uh, so choosing the right Ruby for the job. So traveling Ruby, it's got fast execution and a well-known environment. And a well-known environment is really important because basically I could write my code and run it with normal Ruby and with MRI, and it's basically the same. It is the same, so I didn't have to change anything. The problem is its support. So I'm not sure if it's abandoned or not, but there are some commits lately, but the last version released was 2 years ago, and it was Ruby 2.2.2. There is some activity and some initiative to get the project up and running, and hopefully it will be done because it's a really cool project. mRuby, it's lightweight and it has fast execution, which is really cool. Kind of the bad things is library support, and I don't think it's like a bad thing. It's just basically not meant for the stuff that I was doing. However, I had to try out 4 different HTTP libraries, and each of them had their own problems, especially with HTTPS. So that was kind of a problem, and you have to perform cross-compilation, which if you're really serious about getting into Ruby, try out mRuby CLI. It works with Docker, and you should be up and running quite quickly. And JRuby, it's got simple packaging, which is really great because I was like really fast at doing the bot with JRuby. However, slow execution. It's got slow execution. So basically, there's an asterisk here because there are some ways to speed up the warm-up times with some trade-offs. However, I wasn't able to speed it up too much. So let's talk a bit about alternatives. So I talked a lot about Lambda, but you've got like, Microsoft's got Azure Functions that basically has a similar language support. However, not that many integrations as Lambda has. And then you got Google Cloud Functions, which only supports Node.js for now and is currently in beta. And then you got like IBM and Oracle and a lot of these vendors that are actually getting into the serverless area, which is pretty cool. However, none of them actually currently support Ruby. So one of the options I didn't mention is to run Ruby inside of Docker on some of these. There's even a framework called Kubeless that works on Kubernetes. However, in my opinion, that is not the simplicity I would look for when running serverless functions. So basically, yeah, I wouldn't think that as much as an option. There are even like open source frameworks like for Iron functions and stuff like that. And it's cool that they're open source if they're hosted, but if you have to host it yourself, well, then it's not serverless because you're taking care of a server, right? So, and other things that are mentioned at this conf. So the guys from Fastly mentioned RubyPacker. It's a fairly new project, and I guess you could try out that. And Hiroshi mentioned yesterday RubySnap. And he just created a repository like 2 days ago, so I'm gonna check out that also. So if you're interested in something like that, that may be a really viable option. However, it can only run on Linux, but that's good enough for Lambda. So there's even a site called serverlessruby.org. I don't know how many of you saw this. It was in Ruby Weekly a couple of months ago. It's basically an open petition with almost 1,000 signatures for getting all of these big vendors to start supporting Ruby on their serverless infrastructure. So if you want something like this, go to this website, serverless-ruby.org. Just sign in with your GitHub, and you're automatically gonna sign the petition. And I guess the guy is at one point gonna go and provide these numbers to these serverless providers. in conclusion, this was really a fun experiment and basically to try multiple flavors of Ruby, which I didn't try before. I'm glad that I had the opportunity to show you that you can run Ruby on any of these platforms, no matter if they support Ruby or not. And this isn't like only tied to serverless. Basically, if you ever have some Ruby code that you need to run anywhere else but don't have the Ruby runtime, you can basically do it like this. Uh, However, this is basically far from perfect, and we're not there yet, but hopefully we'll be soon. Basically, that's all. My name is Damir Svrtan. As I told you, I currently live in Zagreb, where I organize the local Ruby Zagreb meetup group. However, I should be moving in the next month to the San Francisco Bay Area and start working for Netflix. And Netflix is actually currently hiring Ruby developers on multiple positions, so if you're interested in hearing more about it, feel free to catch me after the talk or just ping me up on Twitter. That's it. Thank you.
Wow, thanks, Mr. Svrtan, for bringing such a refreshing talk. So, Q&A. Any question? In regards to bots, serverless bots?
Yeah. For mRuby, when you showed the gem config, right, does that mean it just recompiles the entire binary and all those
Yeah,
things are
yeah.
written in C?
Yeah.
You end up with one statically linked executable?
Yeah, yeah.
That's pretty sweet.
That's pretty cool. Yeah. So everybody else wants to go to lunch? Probably.
Yeah, I think they're too hungry. So,
Okay, no problem.
so that's just go there and prepare. Just enjoy your lunch. Yeah, but if you have further questions, you can ask Mr. Svrtan later. Thank you very much.
Thank you.